Hello, class, and welcome to the second video in Chapter 11. This one, as I said in the first one, is just going to be problem heavy. We are going to work through the three other problems that we didn't get through in the first video. So we are going to look at make or buy decisions, whether a company should accept a special order, and what to do with constraints. So you are going to need your handout that I sent out that is posted on Moodle. So if you don't have that pulled up or printed out, go ahead and get that ready now while I get my computer ready here for the whiteboard. So the first thing we're going to look at is make or buy decisions. So if you're a manufacturing company and you're manufacturing something, there could be multiple components to whatever the final product is. As part of the manufacturing process, maybe your company makes every component that goes into that. So an outside supplier comes to you and says, hey, I see you're making all these springs on this machine over here. I can give you all those springs. I can sell them to you for this cost. Okay. So as a manager, you're going to want to look and trace all your costs and find out, is it more profitable for your company to continue making them in-house or to buy them out of house? So if you look at problem number 2, it talks about Troy Engines manufactures a variety of engines for use in heavy equipment. The company has always produced all the necessary parts for an engine, including all of the carburetors. An outside supplier is offered to sell one type of carburetor at a cost of $35 per unit. To evaluate this offer, Troy Engines has gathered the following information relating to its own costing. So if you remember from the first video, we are going to only look at what are relevant costs here. We can do this in two separate ways. You're going to get the same answer either way. We can either do it on a per unit level or on a total level. So on each one, I will make a make or buy heading for it. Okay, so we start looking through. We're just saying what happens. So if we purchase the carburetors from an outside source, of course, there's going to be no cost for us in the make department. We don't have to pay anything, but there is going to be a $35 cost per unit here in the buy column. And again, in the total here, it is nothing. And the problem tells us that we are making 15,000 units. So I'm just going to take my 35 times the 15,000 to find out it's going to cost me a total of $525,000 if I was going to buy them. So now, if I'm going to make them, we use the information given. The direct materials, not going to change. So we'll have 14. Our direct labor is still $10 if we decide to make them. And then we go down to the fixed manufacturing overhead or the variable manufacturing overhead of $3, which is not going to change. I think I'm making my own problem here. The variable manufacturing overhead does not change. And then you get to the traceable fixed manufacturing overhead. Okay, it is listed at $6 per unit, but it has a little star by it. So that means we're going to have to investigate it a little bit further. And when we do, it tells us 1/3 is the supervisor's salary and 2/3 is depreciation of special equipment with no resale value. So again, we have to think back to the first video. What costs are relevant here? What costs can be avoided, okay, if we made them? So the only amount we are going to be concerned about here is the 1/3 of the supervisor's salaries, okay? So of that 6, we are only going to be concerned about 2 because the depreciation is unavoidable. Whether we make them or we decide to buy them, we are going to have the same expense. So, honestly, you could put 6 here, and you're still going to have a 4 that you're going to have a cost. If you were to buy them, you're still going to have it because that is what is unavoidable. So for simplicity's sake, we're just going to put a 2 over here. Okay? And then the fixed overhead manufacturing that is common, remember that is an unavoidable cost. If we decide to buy the carburetors, that common fixed overhead is just going to have to be allocated to other parts of the manufacturing process. We add all these up, and we see that if on a per unit basis, if we were going to make them, it would cost us $29 per unit compared to the $35 per unit to buy them. So in this case, we would tell that supplier, I'm sorry, we're going to continue to make in-house because we can make them cheaper. If you take all these numbers out and divide them out by the 15,000 units, and add them up, so those are total costs. You'll see our total cost if we were to make them were $435,000. If we were to buy them, it would be $525,000, a difference of $90,000. Or here, a difference of $6 times 15,000 units equals a $90,000 in savings. So whether you want to go out and you want to do it all out by the totals, or if you want to do it on a per unit basis, you're going to calculate the same amount of savings or the same amount of extra expenses, deciding on which alternative you have to take. So under question 1 here, we would definitely want to make them in-house. Now the second part of this question, number 3, it says, suppose that we did decide to buy the carburetors, and there is some opportunity cost in this one because we could use that space and we could make an extra $150,000 per year in segment margin or contribution margin by using that space for something else. So it is the opportunity cost. If we decide to make them, we are not going to get that. Okay, so if we were going to get an extra $150,000 added to our profit, if we decided to buy them, we can actually put that on this side, and it is going to lower our total costs. And the $525,000 that it was going to cost us, we can now assume that it's only going to cost us $375,000 if we buy them because of the extra $150,000 profit we are going to make. And with that opportunity cost factored in, now it makes more financial sense to buy the parts from an outside supplier instead of make them in-house. Okay, so that is a simple make or buy decision. So once again, you just look at all the relevant costs that could be used if it is made, compared to all the relevant costs that would happen if you bought it from an outside source. Whichever one is the lowest cost to you, that is the decision as a manager you're going to want to make. Okay, so our next question, we are going to deal with special orders. Special order is when you are a manufacturing company, you're producing something, and maybe somebody comes to you and says, hey, this one-time thing, I want to buy this many, this is what I'm willing to pay. Maybe they have some special terms or special conditions they want you to meet. And this could be common if you're dealing in maybe sports trophies, banners, jewelry, stuff like that. People are always wanting to make something special just for them. If we look at our question here we have a jewelry manufacturer. Imperial Jewelers manufactures and sells gold bracelets for $189.95. The company's accounting system shows that the unit product cost for the bracelet is $149. So, and it breaks down how that $149 is out there between direct materials, direct labor, and overhead. And then it gives us a bunch of other information. A wedding party wants to come buying 20 of those bracelets for $169.95, which is $20 lower than the margin. But they would also like to have a special engraving put on it. And this is going to increase the variable cost by $2 per unit and require the company to buy a machine that costs $250. It also tells us this machine or this tool will have no other use once a special order is completed. All right, so big thing we want to look at here is the difference between the fixed cost and the allocated cost, especially when it comes to manufacturing overhead, in order to see what the profit's going to be. Okay, so again, we're only going to look at the relevant costs. So what we're going to do is just make out a mini income statement to see if this company did take this order, how would it affect their income? If it makes their income go up, it's an order you want to take. If it makes the income go down, it's an order we do not want to take. Again, we can do this on a unit level. I'm going to do it on the inside and then on a total level, because we are going to have some fixed costs, and you'll see how this is going to play in here in a little bit. But our revenue, we're going to get 169.95 per unit for selling these watches, okay, or the bracelets. Makes our total 3,399. So now we start looking at our costs. So first we have direct materials. I'm just going to leave it the same at its 84 right now. Our direct labor is 45. We have an extra material that we're going to have to use in order to make these special bracelets, and it told us it is going to increase the direct material cost by $2 a bracelet. So I'm going to label it in here as extra materials and increase my variable cost here by $2 per unit. If you wanted to add it into your direct materials and just make that 86, I can see that, and that would be fine. And the other thing that we are going to put into our variable cost is manufacturing overhead. If you keep reading down at the final paragraph, it tells us $4 of the overhead is variable with respect to the number of bracelets produced. So we're going to, and that is the only thing that is relevant. The fixed overhead that is not dependent on how many bracelets are produced, that is going to be called the common fixed cost, which will have to be reallocated, or it will remain the same whether we produce these bracelets or not. So once again, not relevant to this decision. Okay. Add all those up, we get a total variable cost of $135. You can do the math out. All these across, all these we're taking it times 20 because we were selling 20 bracelets, remember? So we have 1680, 900, 80, and 40. That is our total variable cost. So we want to look over at our total line now. So we have 3,399 of our total cost minus the 2,700 variable cost. It's just a contribution margin of $699. You have to remember now what other kind of stuff we have. We have to buy the special piece of equipment or the special tool in order to do this job. So that is going to be a fixed cost. It's $250 to buy that tool. So after we've taken all our variable cost here, we subtract our fixed cost out from our total contribution margin. And we are showing that we are going to make a $449 profit if we accept this special order job. Okay. You can't just stop right here and think, well, our selling price is greater than our total variable cost per unit. So of course we can do it. It's still a good deal because of the extra fixed cost that becomes involved. So Well, you can do it out on a per unit basis, but then you want to multiply it out, get your total, put your fixed cost into that total to get a total profit. So yes, in this case, accept the job of doing the bracelets for the wedding party. Okay, finally, we are going to talk about constraints. Constraints occur in a manufacturing company where you cannot possibly produce as much as you can sell because of some factor. Maybe it's machine hours. Okay, you're making 3 different products and you could sell 3,000 products of them all, but because of the amount of time you have on the machine, you can only make a certain amount of product. Or maybe it's a material restraint. And maybe everything you take requires steel and there's a shortage of steel going on. So you have to determine what you are going to produce with the limited amount of resources that you have in order to maximize your profit. So our question number 4 here, Outdoor Luggage Incorporated makes high-end hard-sided luggage for sports equipment. They have 3 popular models, their ski guard, their golf guard, and their fishing guard. Okay, and it gives us a selling price per unit, a variable cost per unit, how many minutes it takes on the machines, and how many plastic pellets it takes in order to make each one of these pieces of luggage. So if we look at it as required, it says that total time available on the plastic injection molding machine is the constraint in the production process. So anytime we have a constraint, what we are going to want to do first is we are going to want to find out our contribution margin per the constraint unit. Okay. So if you remember, contribution margin is our selling price minus our variable expense. That will get us our contribution margin per unit. And then we're going to look at the constraint. So in this case, it is minutes spent on the machine. So we're going to find out what our contribution margin per minute is. Okay, so for example, our ski guard has a selling price of 200, has a cost of 60 to get us a contribution margin per unit of $140. The problem tells us it takes 2 minutes on the machine. So do we divide that by 2 minutes? And we get a contribution margin of $70 per minute. So we will do that the same with all 3 of our products here. The golf guard sells for 300, has a cost of 140 for a contribution margin of 160. It takes 5 minutes. We get a contribution margin of $32 per minute. And for our fishing guard, selling price is $255. The cost is $55 for a contribution margin per unit of 200, but it takes 4 minutes to make. So we get a contribution margin of $50 per minute. That is what we are going to base our decision off of. Okay. So for every minute we run this machine, we are basically producing a contribution margin of $70 for making the ski guards. So we're going to run that machine and produce as many ski guards as we can up until the quantity that we want to produce to meet our demand for those. After we make as many of those as we can, since the restraint, we're going to move on to our fishing guards because they produce the next highest contribution margin per minute. What we're doing is we're maximizing our constraint. Since we only have so many minutes, we want to use that machine to maximize profits the best we can. Okay, so that is your answer to part 1 there. Okay, so what is the contribution margin per minute? And for number 2, which product offers the most profitable use of the plastic injection molding machine? It is the ski guard. Okay, ski guard is definitely our best one. So when we get to number 3, it says, well, what if we assume that there's a severe shortage of the plastic pellets? So now it's the direct materials that are going to be the restraint in this problem. So now we're just going to have to, instead of doing it by how many minutes on the machine hour, do we get to this point? we're going to divide it by how many pounds of pellets it uses. 7, 4, and 8 respectively. It gives you the problem of how many pounds were used. So now our contribution margin becomes this amount per pound for each one of these problems. For each one of these products, I should say. So our ski guards are now, contribution margin is $20 per pound of pellet. Golf guard is $40 per pound of pellet, while the fishing is $25 per pound of pellet. So if pellets were our constraint, if ours was our direct materials, we want to use our pellets in the most efficient way possible in order to maximize our profits. So we are going to make the golf guards first. We're going to make as many of those as we can up until we run out of the material available to meet the demand for those, and then we'll move on to the fishing. Okay. What is very interesting about this thing is our fishing guards here have the highest contribution margin per unit. We sell them for $255, and it's only $55 to make. We make a total of $200 profit each time we sell those from the contribution margin, which is way better than the ski guards and the golf guards. But so all things being equal, it would seem it would make the most sense to make the most fishing guards to match their demand, sell them. We would get the highest contribution margin per unit for those. But as you notice, when we went through both of these, the fishing guards were not the best thing to make anytime a constraint was thrown in there. Because then we're not just looking at the total contribution margin. You have to take into account how many minutes or hours on the machine that you have, or how many pounds of material you have. And that can make all the difference in the world. Okay, so your homework is just, I think, 8 or 9 questions. You're going to have a couple of each of the 4 that we went through. If you guys have any questions throughout the week, please send me an email. I do not intend on making another video for this chapter for you guys, but I will be available to host a meeting Friday morning if anybody is working through the homework and has any questions. And as I said, email me if anything comes up, and I will get back to you as soon as I can. Enjoy the rest of your week.